Welcome to our HYDAC studio. Today I'm going to introduce you our specific HYDAC smart sensors. Our unique HYDAC smart sensors provide numerous valuable sensor and diagnosis information beside the actual process value. Accessibility is given via IO-Link, a worldwide standardized digital interface, and it can be done with a PLC or also from the remote with a particular condition monitoring tool like our HYDAC CMX software, but it can also simply be done with a browser. Here we see a HYDAC fluid wall for a machine tool. The system is equipped with IO-Link master units and our HYDAC smart sensor. The system is connected to our HYDAC intranet, and I connect to the system with my browser by entering the IP address. I am now connected with the IO-Link master, and here at port 3 we have a smart pressure sensor of our HPT146S series. This sensor was damaged in a different hydraulic application, and now we'll see what it can tell us about what happened in the system. First of all, the process data. We see a live value of 1 bar, even though the pressure is not connected to a hydraulic system. This shows us that the sensor is obviously defective. In the parameter menu, we have access to a number of sensor identification details like vendor name, product ID, serial number, and so on. Here we have access to a number of sensor settings like a pressure filter constant to smooth the output signal, 0-point calibration, and all kind of switch point settings. Now we come to the unique smart information which only our specific HYDAC smart sensor provides. Here we have the actual pressure with minimum and maximum value, our 1 bar, which we've seen before. The sensor detects the internal device temperature. We see the current value, min, max value, everything is okay so far. The sensor does also count the operating hours, and it calculates a temperature normalized operating time, the so-called Arrhenius value. The Arrhenius value is a valuable information about the aging speed of the system. Next, we see a comprehensive statistics of all the measurement data the sensor has seen during its lifetime and events that occurred. Our minimum and maximum values show clearly that the sensor is defective. Minus 11 bar is physically not possible, and the maximum value of 48 bar significantly exceeds the permitted overload range of 32 bar which the sensor provides. We see that a number of underrun and overrun situations occurred. Specification limits have been exceeded. The permitted overload range was exceeded at least once, and numerous errors occurred. In the lifetime pressure statistics, the sensor counts the time. It measures values in specific measurement ranges, and we see that specifically in the overload range, exceeding 16 bar, for many minutes in total, the sensor was exposed to high pressures exceeding the nominal pressure range. In the same way, like this pressure statistics, the sensor records and stores information about the internal device temperature. Here we see the average value, minimum, maximum value, number of underruns, overruns, measurement errors, and so on. Obviously, regarding the device temperature, everything is okay in our device. All this data is stored over the entire lifetime of the sensor in a non-volatile memory and cannot be reset by the operator. But in parallel, we have a second memory section in the sensor which can be reset via IO-Link command, and this enables the operator to monitor specific time periods beside the entire lifetime history of the sensor. The HYDAC smart sensor is a valuable data source for effective condition monitoring. It sees details which a PLC cannot see through a simple binary switch or an analog transmitter, and it helps with error finding and analysis. Thanks to its connectivity via IO-Link, It enables new services like remote diagnosis. This reduces machine downtimes and increases the machine productivity. A very good selling argument for the machinery maker and a good buying argument for the client, thanks to HYDAC smart sensors.